Pluto, our icy neighbor beyond the solar system, just exhibited an insane variability that shocked the entire space industry. This new discovery changes everything that we knew about the planet. While Pluto was previously thought to be an icy dwarf planet with little to no activity, scientists just discovered stunning images of features that have never been seen before in our solar system when they explored the dwarf planet. What have we learned about this dwarf planet? How did the discoveries affect Earth? Could it be a hotbed of alien activity? And why is it more than the cold, gloomy place we first believed it was? Join us as we take a look at scientists' insane new discovery on Pluto. Pluto was demoted to dwarf planet status in 2006 after the International Astronomical Union adopted a new definition for planets, and Pluto failed to meet the requirements, much to the dismay of many. Despite its diminutive size, Pluto packs a powerful punch. It's smaller than our moon and less than half the width of the United States. Pluto's 5 moons, the largest of which is Charon, are so comparable in size that they orbit each other like a double-planet system. As a result of its July 2015 flyby of Pluto and its moons, NASA's New Horizons spacecraft has changed the way scientists think about Pluto forever. The mission's data continues to aid researchers in their quest to learn more about the dwarf planet and the icy objects that circle it near the edge of our solar system. The dwarf planet lies in the Kuiper Belt on the outskirts of our solar system and is the largest of the many frozen objects orbiting at that distance from the Sun. Mountains, valleys, glaciers, plains and craters abound in the frigid globe, which has an average temperature of negative 387 degrees Fahrenheit, negative 232 degrees Celsius. Standing on the surface, you'd witness a panorama reminiscent of the Rocky Mountains with blue skies and scarlet snow. A recent photo analysis revealed a rough patch on Pluto that is unlike anything else on the small world or in our cosmic vicinity. This lumpy region is home to a smattering of unusually enormous ice volcanoes unlike anything else we've ever seen in the solar system. The location is southwest of the Sputnik Planitia ice sheet, covering 621 miles 1,000 kilometers of the ancient impact basin. It mostly consists of lumpy water ice that is covered in volcanic domes. Wright Mons and Piccard Mons are 2 of the largest. Piccard Mons is around 22,965 feet 7 kilometers high and 139 miles 225 kilometers wide, whereas Wright Mons is roughly 13,123 to 16,404 feet 4 to 5 kilometers tall and spans 93 miles 150 kilometers. The Mauna Loa volcano in Hawaii is one of the largest volcanoes on Earth, and Wright Mons is thought to be comparable in size. Some of the domes seen in the photos combine to form even larger mountains, but what may have caused them to exist? It all boils down to ice volcanoes. Ice volcanoes have been discovered in other parts of the solar system. They produce a new landscape by moving material from the subsurface to the surface. When the water reached the freezing temperatures of Pluto's surface, it swiftly turned to ice. Pluto's snow-covered mountains look like they belong on Earth, but they are in fact completely different from our own planet. It's hard to compare the appearance of these features to any other volcanoes in the solar system, be it icy or rocky. They started out as mountains, but there is no caldera at the top, and they are covered in big bumps. For decades, scientists believed that Pluto's stony core lacked the internal energy necessary to stoke volcanoes. They believed that several eruptions would have been required to form the area. Additionally, the lack of impact craters in the area, which can be observed across Pluto's surface, shows that the ice volcanoes were active very recently and that Pluto's interior has more residual heat than expected, implying that our understanding of planetary systems is incomplete. As far as geological timescales go, the ice volcanoes may have been active as recently as 100 million or 200 million years ago. Observing Pluto's ice volcano would be an experience unlike anything you've ever seen before. On this dwarf planet, instead of erupting gases and molten rock, the cryovolcanoes on this dwarf planet expel massive amounts of ice, most likely frozen water. While flowing out of its volcanic vent onto Pluto's surface, the frozen material would most likely be a slushy mix of ice and water, or more like toothpaste. The explanation for this is that liquid water cannot last long on Pluto's surface due to its extreme temperature. In any event, the flow of material created the gigantic domes that we see today and the bumpy topography that can be observed across this region. The team working on New Horizons was only able to observe the region for about a day as it flew over this region, therefore they were unable to observe any present ice volcano activity. In theory, the ice volcanoes could still be active at this time. They could be like Earth's dormant volcanoes, which become active again after a period of inactivity. In addition, some scientists believe that Pluto has a liquid ocean beneath its ice cover that is around 249 miles thick. According to this theory, Pluto's moon Charon developed later in the dwarf planet's existence as radioactive materials decayed near the rocky core. A subsurface ocean could have formed as a result of this heat. Contrary to popular belief, however, the data from New Horizons suggests otherwise. According to new research based on that data, Pluto may have been formed in a heated formation scenario. Those extensional fractures detected by New Horizons in Pluto's ice surface could be caused by the gradual freezing of the liquid ocean over time. These ice volcanoes may indicate that Pluto's once prominent subsurface ocean is still present and that liquid water may be present within a short distance of the planet's surface. In conjunction with previous findings of Pluto's interior being warmer than previously thought, these new findings raise intriguing questions about Pluto's potential habitability. However, other scientists claim that any organism attempting to thrive there will face numerous difficulties. Even if the volcanism is episodic and hence the availability of heat and water is intermittent, life would still require a constant source of nutrients. Sending an orbiter to Pluto to investigate its fascinating subsurface would be necessary. We may utilize ice-penetrating radar on a future expedition to see directly inside Pluto and observe what the volcanic plumbing looks like. New Horizons also revealed the unusual mechanics of Pluto's beating heart-shaped glacier, which is about the size of Texas and even helps generate the planet's wind. The heart-shaped feature is known as Tombaugh Regio, named after Clyde Tombaugh, the astronomer who discovered Pluto in 1930. Nitrogen ice dominates this part of the dwarf planet, which is home to the deep basin known as Sputnik Planitia due to its elevation of 1.9 miles below the planet's surface. The basin is the left lobe of the heart, with nitrogen glaciers and highlands on the right side. Pluto's frozen nitrogen core thaws enough to turn into vapor throughout the day. It begins to freeze over again at night. Scientists refer to this as Pluto's heartbeat, which regulates nitrogen wind circulation in the planet's atmosphere. The wind is created when Pluto's frozen heart beats. Because expansion would occur throughout Pluto's history, this protracted, progressive freeze of the subterranean ocean could also explain the variety of characteristics on the dwarf planet's surface. Pockmarked surfaces were also found on Pluto and Charon in photos taken by New Horizons. Large craters dot the landscape. It appears from the craters that Pluto and Charon were struck by small Kuiper Belt objects less than 100 kilometers in size. The fact that no impact craters smaller than 13 kilometers in diameter were identified suggests there are fewer Kuiper Belt objects smaller than 2 kilometers that astronomers had projected based on what scientists know about impact crater formation. This lends credence to the theory that Kuiper Belt objects may not be chunks of space rock generated by collisions, but rather unbroken leftovers from the formation of the solar system billions of years ago. Also, the dunes on Pluto are only one of the planet's many surprises. On Pluto, the dunes are not composed of sand like that of Earth, but of solid methane ice grains that are molded by the wind. Dunes are more common than you might expect in our solar system. They exist solely on Earth, Mars, Venus, Saturn's moon Titan, and comet 67P. Due to the fact that these dunes are mostly undisturbed on Pluto's frozen crust, it's likely that they were produced within the last 500,000 years, or perhaps less recently. Pluto creates an age-old dilemma in this way. Polygonal shapes and features on the dwarf planet's surface indicate that it's a young and active geological system. The surface is only a few thousand years old despite the dwarf planet's 4.5 billion-year-old age overall. A thermal convective overturning of the ice is most likely the cause of this action. These are only a few of the discoveries made possible by New Horizons data, and more will be found in the future as scientists sort through the massive amount of data collected during the flyby. These are just a few of the discoveries of Pluto. More discoveries will be uncovered in the future as scientists examine the dwarf planet. Let us know what you think of the dwarf planet discoveries in the comments section below.